presenting you Hazelnut. Hazelnut is a project which main idea is to generate Smalltalk images by exercising the image construction and initialization, which is not normally done in our normal images every day. The main idea is that these new images will be used to support the Pharo modularization and evolution, like for example by creating Pharo kernel images that will grow using the Tanker package manager. As a side effect, Hazelnut will support experimental images, like images with different meta models or with modules or namespaces, and will support the creation of minimal images with the specific purposes. So now I will show you two different demos. The first one is the creation of a Pharo kernel image from source code. The source code resides on GitHub, but I have it now on my hard drive. So I have the source code of all the Pharo kernel classes, and what Hazelnut will do with this source code is to compile it, generate an object graph, and dump it into a new image file. In order to do that, Hazelnut needs a seed object. A seed object is an object that contains all the specification needed in order to create a new image. So it contains all the specification loaded from the source files and another information like how to initialize some objects or stuff like that that is not normally in the source code. So first we'll delete the old image files, we generate the seed. This seed generation loads all the source code files and generate models for it, so it takes like 10 seconds. After that, we use that seed in addition with the Hazel kernel builder to generate a new kernel. This kernel is just an object graph that is completely wired and will represent the new image. So we execute this, and once it is done, we have our new image living inside this image. This image is represented by the Bootstrap environment. So now what we will do is to write our Bootstrap environment into a new image file, which will be called kernel.image. Do it. Finally, when this is done, we will be able to see a kernel.image file, which is 2.2 megabyte large. But what can we use this for? The main idea is that this image will be able to grow, to load packages on top of it. So to do that, we have Tanker inside this little image, and to test how healthy this little image is, for example, we have a series of Jenkins jobs built to test it. So for example, we have a kernel image, and we load SUnit on it, and after that we load the kernel tests, and then we run the tests of the kernel on this little image, so we can know how healthy this image is, or how are the dependencies between different packages. The second demo is showing us how to build a minimal image. So for example, here we have the Pharo candle image, the Pharo candle source code, which is very small, it has very few classes, and we will generate a new image from this source code. If you look at how we do that, it's kind of the same. So we take the source from a different folder, so we will generate a different seed, but then the process is the same. We tell the kernel builder to build a kernel, and then we dump it into a candle.image file. So we generate the seed, build the kernel, and dump it. And after that, we have a candle.image file, which is 85 kilobytes large. It is a really small image. What can it do? It can write files, do math, use semaphores, several stuff, but it doesn't have all the complexity of our original Pharo kernel. So let's execute this candle image to see what it does, and let me show you. I will execute this candle.image. It finished, and after executing, we have this log.txt that says welcome to Pharo Candle Edition. It shows us how many bytecode per second it executed and how many message sends per second it did. So as we see, we have a little image, 85 kilobytes, that is working, just loading a specification. We can of course make the specification smaller to generate even smaller images, but this is kind of a toy image. The main idea is to generate these kernel images, a good kernel image, to support how Pharo will grow over the time. So this was Hazelnut. I hope you enjoyed it, and a plus.